Hello dear students, just I am continuing the exercise 16.1 now. Up to the question 6 we have already completed. Now solution of question 7, that is just writing what sample space. Okay, so for that just we are denoting by symbols of activity here. A die, the question 7 is what? One die of red color and on of white color and on of blue color. Red, white and blue color die, blue color are placed in a bag. One die is selected at random and rolled, and its color and the number on its uppermost face is noted. Describe the sample space. Means what is here? In one bag, in a bag, red color, white color and blue color dice. There are 3 dice are in a bag. Just we are selecting from the bag at random one of the die, and we note its color and then the number on the topmost face. Okay, because selected and rolled. In bag there are 3 balls, 3 dice, different colors. So one of the die is selected and rolled, and color and top faces number are noted. So what will be the sample space of this experiment? Okay, so here just we have to discuss a die having 6 faces with a number 1, 2, 3, 4, 5, 6. That is one time rolling. There are 6 possible outcomes, and also here color is noted. So there are 3 colors. So let us suppose that red color die is denoted by R. Let R, W and blue be R, red, white and blue color die. Then as a die having 6 faces with numbered from 1 to 6, the sample space of experiment of the given experiment, you can write given experiment is given by what? Just select and note color. Suppose red color is getting and rolled over this. Then 1, 2, 3, 4, 5, 6 with R. So R1, R2, R3, R4, R5, R6. If white color die is selected, then W1, W2, W3, W4, W5, W6. If blue color die is selected, then these are possible outcomes and put in a set that is called sample space. So this is sample space for event experiment given in the question. Okay. So by denoting, you can write like this. This is sample space. That means these are the outcomes of our experiment. Experiment is what? Selecting a die from back and rolled over. Selecting color mention ROWB and rolled over, then with each color maybe 1 to 6, 1 to 6, 1 to 6. That's why these are the sample space. Now question 8. Suppose taking question 8. Here question 8 is what? An experiment consists of recording boy-girl composition of families with 2 children, means each family having 2 children. Okay, so what is the sample space? If we are interested in knowing whether it is a boy or girl in order of their births. That means each family having 2 children, boy or girl. And by order of their birth, just order of their birth means we are interested to know order of their birth. That is first birth days for boy, then we are writing B and then G. If B for boy, G for girl. And if first birth is girl and then Z first and then B. This is our order. By order mentioned, 2 children. Just we are knowing. So here 2 letters will be there. B, G, G, B. Or maybe 2 children are there. Maybe boy, maybe girl, maybe both boy, both girl. Maybe boy, one another girl. Okay, so here just for denoting what we have to do here, when, what is the question we are interested in known? If we are interested in knowing whether out of 2 childs, it is a boy or girl of in the order of their birth, then your sample space will be what? If B and G denotes boys and girls respectively, okay, B boys, G girl, then the required sample space for, then not required, then the sample space of the event, sample space of the sample space when considering the order, considering the order of the birth of boy or girl, okay. When consider the order of the birth of boy or girl, then the sample space when this is given, what will be? Suppose Z, both are girl, then first Z, then another Z, and girl, boy, then G first and then G, or maybe B, and first B, then BG or BB, okay. If this is, if both are girl, if both are boy, then this, both are girl, then this, if girl boy and boy girl, then this will be the sample space. Two childs are there. This first part, 8 first and 8 second, sample space 8 second. What is 8 second? What is the sample space if we are interested in the number of girls in the family, in the number of girls in the family, if we are interested in the number. So we know each family having 2 children, so maybe both are girls, maybe one boy, one girl, maybe no girl. That means 2 girls may be there, 1 girls may be there, no girls may be there. That is number of girls, 0, 1, 2 maybe. So if we are interested to know the number of girls in the family, then the sample space is given by what? S equals to 0, 1, 2. Number of girls, maybe 0, 1 or 2. So this is sample space. This will be the sample space. Sample space is a set number, 0 girl, 1 girl, 2 girl. One family having 2 children. That's all. Okay. So by this type of process, you can write the sample space for an experiment given in the question. Okay. Now take question 9. Okay. Here a box contain 1 red, 3 identical white balls. 1 red and 3 identical white balls. 2 balls are drawn at random in succession with replacement, without replacement. Write the sample space for this experiment. Here, what is given? 1 red, 3 identical white balls. In the question 9, here we see that a box contains identical white balls, means all balls are same you cannot differ, but 3 white balls are there. Total balls, how many balls are there? 4, because 1 red and 3 white balls. Okay. So here we can numbering how? Denoting, red ball is denoted by R and white ball is denoted by W. Okay. Not 1, 2, 3 because they are identical ball. So just we are denoting red and white ball by R and W. Then 2 balls are at random succession. Here just let R and W denotes the red ball and white ball respectively. Okay, then the sample space. Then the sample space okay, of for the given experiment what is given experiment? 2 balls are selected at random, selecting 2 balls at random in succession without replacement. 2 balls are drawn at random in succession. In succession means what? Without replacement. Without replacement. The space for this is given by sample space is equals to without replacement. Succession means just box contains balls, 2 balls are selecting. So in succession without replacement means 1 ball drawn and then another ball drawn. 1 ball drawn and cannot we have not put the ball in the box and again select another ball. Okay, so selecting balls in succession 1 by 1 without replacement. Just we are not putting the ball after selecting, first selecting. So 2 balls are drawn at random in succession 1 by 1 without replacement. Just not put back it in the box. Is given by. Okay. So if we are getting in first selection red, then another maybe what? Because 1 red ball and 3 white ball. So 1 red is selecting, then another ball may be white. Okay, and then if white ball are getting in first selection, then in second time maybe we may get what? The red ball. Okay, and RW, WR, and also we may get like this. So 3 elements are there. RW, WR, WW. RW, WR, WW. This is sample space. Okay, in first selection, if we get red, then remaining 3 are white. So next is white. If first we get white, then we can get in the second time either red or white. So red or white. So this is record sample space. Okay. So just using this type of discussion, you have to write the sample space. Take question 10. Question 10 is an experiment consisting of tossing a coin and then throwing it second time if a head occurs. Okay? Means experiment consists. What is the experiment? Just tossing a coin and then throwing it second time if a head occurs first time. Tossing coin and again we toss this coin if we get head first time, and if a tail occurs first time, then roll a die once, 1 times. Find the sample space. Okay, so very simple. We know tossing a coin having 2 possible outcomes, head and tails. Suppose each head, 3 tails. And if head, here we can write required sample space. Required sample space is what? Will be first time toss we get head. If we are getting head, then what? Head, and again we toss it. So with head, maybe head or tail, maybe head or tail with this head. And if tail, then we roll a die once, 1 time. So if getting tail, then with tail there may be 1, 2, 3, 4, 5, 6. So T1, T2, T3, T4, T5, T6. This may be the possible outcomes. So T1 to T6. Here H, H, T. So this is our sample space. These are the outcomes of experiment. If first time head occurs, then again toss the coin. If first time tail occurs, then roll a die. This is the sample space. Okay. Question 11. 11 is this. Suppose 3 bulbs are selected at random from a lot. There are a lot of bulbs. Just we are selecting 3 bulbs at random. Okay. And each bulb is tested and classified as defective or non-defective. Defective D, non-defective N. Write the sample space of this experiment. So very simple. This is just like tossing a coin 3 times. Yes or no? Yes, na? Because why? Defective, a lot of bulbs, we are having a lot of bulbs, they are defining like defective or non-defective. So defective, suppose defective are denoted by D and non-defective are denoted by N. Then there are 2 types of bulbs are there in a lot. Just we are selecting 3 bulbs. We are selecting 3 bulbs. Then suppose D defective and N first bulb. select, because 3 balls are selected at random from a lot. So 3 balls. So first ball, 1 ball is defective, maybe first ball. Then with this, maybe non-defective. With this ball, second ball, maybe what? Defective, non-defective. Defective, non-defective. With this, defective, non-defective. Defective, non-defective. Defective, non-defective. Defective, non-defective. So 3 balls. Sample space will be what? B, D, D. First time. Maybe this, B, D, N. Maybe this, D and D. D and D. Maybe this, D and N. D and N. 4. And the remaining 4 are this. N, D, D. N, D, D. And then N, D, N. N, D, N. And 2 are remaining. What? N and D, N and N. N, N, D, and N, N, N. So this is sample space. If defective is denoted by D and non-defective is denoted by N. Then by using this type of diagram, you can write the sample space for the record experiment. What is experiment? Just selecting 3 bulbs from a lot, where D is for defective bulbs, N is for non-defective bulbs. Each balls are marked as defective, either defective or non-defective. Okay. So take question 12 here. A coin is tossed. If the outcome is head, a die is thrown. If die shows off an even number, that die is thrown again. Okay, so what is? A coin is tossed. If coin shows head, first time, coin is tossed, coin shows head, then a die is thrown. And if die shows even number, then again die is thrown. The 3 stages there. Okay? Shows up an even number, then die is thrown again. What is the sample space of this experiment? Here, if tossing coin shows tail, nothing to do. So, one possibility is what? Only tail. And another possibility is we have to write. Okay. So here, just see. We know tossing a coin having 2 possibilities, head and tail, and throwing a die having 6 possibility, getting 1, 2, 3, 4, 5 or 6. So here 12. Just how can we write? Just first of all you have to explain. Tossing a coin having possibility, getting head, H, tail, T, and throwing a die having possibility of getting 1, 2, 3, 4, 5 or 6. That is even number 2, 4, 6. Odd number 1, 3, 5. Okay. So required sample space. Just I am writing only sample space. How can you write? Just describe first about tossing coin, throwing die, and then you can write sample space. Okay. First of all, if toss a coin, then if we are getting head, then our process will be continued. If we are getting only tail, then nothing to do. So If tell, then finish. And if getting hate. If getting hate, we are throwing die. So with this head, we can have number 1, 2, 3, 4, 5, 6. 2, 4, 6 are even number. If 2, 4, 6 are getting, then again throw die. If 1, 3, 5 are getting, nothing to do. So H1, H3, H5 will be also there. 1, H3, H5. This will be also outcome, possible outcome. And again, if H and 2, then again 1, 2, 3, 4, 5, 6. 4, then 1, 2, 3, 4, 5, 6. 4, 1, 2, 3, 4, 5, 6. 4, 5, 6. So just we have to write what? H2, 1 and up to 6. H21, H22, H23, H24, H25, H26. H4, 1, H42, H43, H44, H45, H46 and H6, 1. Just we are doing this, na? H61, H62, H63, H64, H65, H66. These are the H66. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 possible outcomes are there. They are written in set notation. This is sample space. This is our sample space. Okay. For the question 12, 22. Clear? So this is sample space. And next question is 13. Okay. Question 13. The numbers 1, 2, 3, 4 are written separately on 4 slip of papers. Means 4 slip of papers, number written, 4 slip, 1, 2, 3, 4 are written on the slip. The slips are put in a box and mixed thoroughly. That is just in a box. There are 4 slips of paper. 1, 2, 3, 4 are written on that paper separately. Okay, and a person draws 2 slips from the box one after the other without replacement. Just from the box, a person just selecting 2 slips one after other in succession. That means without replacement. Okay, without replacement. And describe the sample space for this experiment. So here, question 13. 4 slips having numbers, a box, containing 4 slips with numbers 1, 2, 3, 4 on them separately. With numbers written on them. Numbers 1, 2, 3, 4 written on them separately. The sample space. The sample space for experiment selecting or drawing a person draws two slips from the box, two slips from the box, okay, one after the other, without replacement. This is the experiment is given by what? Numbers are there, na? Two slips draws. That is, numbers are there. Order pair of numbers will be there. Okay. So what? If first number is 1, then remaining 3 numbers can be get with 1, then 1 2, 1 3, and 1 4. 1 if getting, then 2 3 4 may be there. If 2 getting, then 1 2 3 2 4. If 2 getting, then with 3 1 3 4 1 3 4. And if 3 getting, then 1 2 and 4. If 4 getting, 1 2 3. So these are the elements. 9 elements are there. Okay. So here 1 2 3 4 5 6 7 8 9 10 11 12. How many elements are there? 1 2 3 4 5 6 7 8 9 10 11 12. 12 elements will be there. Because 2 slips. First 1, then remaining 3 may be with 1. If 2, then remaining 3. 3, then remaining 3. 4, then remaining 3. Just write like this. This is one sample point. Sample point means elements, possible outcomes. So this is sample space for question 13. Okay. Now take question 14. Here 14. An experiment consisting rolling a die and then tossing a coin if the number on the die is even. Just what is our experiment here? Rolling a die. If we are getting even number, then we toss a coin. Okay. Consider rolling a die and the tossing a coin once. Rolling a die, rolling a die and then tossing a coin one times. If the number on the die is even, if the number on the die is odd, then coin is tossed twice, 2 times. Means even number, after rolling a die, if we are getting even number, then 1 time toss a coin. If we are getting odd number, then 2 times tossing coin. This is our experiment. So for this experiment, we have to write sample space for the question 14. So just write the sample space here. Here also we are denoting possible outcomes of tossing a coin are by heading H and T, head and tail, and rolling a die or having 1, 2, 3, 4, 5, 6. Even numbers 2, 4, 6, odd number 1, 3, 5. So, the required sample space is, just we are writing sample space. You have to discuss about on tossing a coin where we will have two possible outcomes, getting head and tail denoted by H and T, and rolling a die we will get possible outcomes, 6 outcomes, 1, 2, 3, 4, 5 and 6. Okay. Now, just what is our experiment? Rolling a die, getting even number. Then one time tossing coin. Even number. The even number means what? 2, 4, 6. Tossing a coin. That is head, tail, head, tail, head, tail. This first time, this second time. So 2H, 2T, 2H, 2T, 4H, 4T, 6H, 6T. So 2H, 2T, 4H, 4T, 6H, 6T. One time tossing, first time, second time. If we are getting 1, 3, 5, if we are getting 1, 3, 5, these are odd numbers. 2 time tossing. 2 time tossing means head, tail, head, tail, head, tail. 2 time tossing. One time is this, another time with head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. Just we can get like this. Okay, so what will be remaining here? 1 HH. So 1 HH, 1 HT, 1 TH, 1 TT. Okay. Now 3 HH, 3 HH. Sir, just you can get 3 HH, 3 HT, 3 HT, 3 HT, 3 TH, TH, 3 TT, 3 TT, 4 HH, 4 HH, 4 HT, 4 HT, 4 TH, 4 TH, and 4 TT. So these will be our possible outcomes for this experiment in the given in the question. Okay, so just you have to write this sample space in this way. Okay, 2 times that is this. So 5 TT, 1, not 4, 5. Sorry, 5. This is 5. This is 5. 5. This is 5. This is 5. This is 5. 5 TT. Okay. So 4, 4, 8, 12, and 6. 22 elements are there. Okay. Now question 15. Question 15 for writing sample space. A coin is tossed. If it shows a tail, we draw a ball from a box which contains 2 red, 3 black balls. 2 red, 3 black balls. Okay? A box contains. So, 15 number question. 15. A box contains 2 red and 3 black balls. 2 red, R1, we can write R1 and R2 ball, and 3 black balls, B1, B2, B3. Suppose we are denoting this, just you have to write it in details. Box having these 2 red ball and 3 black balls. A coin is tossed. If coin shows tail, then a ball from the box is drawn. A ball from the box which contains this, we draw a ball. Throw a coin, tossing a coin, shows tails, then we select, draw a ball from the box. Okay. If it shows head, we throw a die. That is 1, 2, 3, 4, 5, 6. Maybe output in seconds. Find the sample space for this experiment. Just you have to discuss first about tossing coin having 2 outcomes, head and tail, HT, and throwing die. 6 possibilities, getting 1, 2, 3, 4, 5, 6 as a number, and events selecting a ball from the box having this type of balls. Okay, so required sample space. Is what? A coin is tossed. If it shows tail, suppose it shows tail. Coin shows tails. Coin shows tails, then we draw a ball from box. So with this tail, this 5 may be. So T R1, T R2, T B1, T B2, T B3. Maybe any of the 5 ball with T. So this, and if coin shows head, then this will connect from here, this will connect from here. So H 1, 2, 3, 4, 5, 6. So here H 1, 2, 3, 4, 5, 6. H 1, H 2, H 3, H 4, H 5, H 6. So this is required sample space. Okay. With tail, one of the ball. With head, one of the numbers. This is required sample space. For the question 15. Okay. Now question 16. A die is thrown repeatedly. A die is thrown repeatedly until a 6 comes off. What is the sample space for this experiment? Just we are trying to identify what will be the sample space for this. A die is throwing repeatedly until a 6 comes up. Die is throwing repeatedly. Clear? a die is thrown repeatedly. A die is thrown repeatedly until a 6 until a 6 until a 6 comes up. This is our experiment. This is experiment. Sample space for these experiments. Okay. So, in these experiments, 6 may comes in first attempt, 6 may comes in second attempt, in third attempt, in fourth attempt, and so on. Clear? Until 6 comes. So here, if in first attempt we get 6, then our sample point or possible outcome will be what? Only 6. Sample space for this experiment is given by. How can you write? In this experiment, just you can write in this experiment just you are writing like this. In this experiment, 6 may come up in first, come off on the first throw. First throw, the second throw, come off on the second throw, on the third throw, and so on. Okay? And so on. Okay? And so on till six is obtained. We can write like this, na? First, 6 may comes up. 6 may comes up on the first throw. 6 may comes up on the first throw, second throw, third throw, and so on till 6 is obtained. Till 6 is obtained. That is, so the sample space can be written as follows: as equals to, if 6 comes, then finish first attempt. And if not 6 comes in this first row, then if 1 comes, then 1 comes. First attempt. Then in second may come what? 6 finish. If first 2 comes and then second come 6 finish. Similarly 3 comes 6 finish. Fourth come then 6 finish. Fifth come then 6 finish. And 6 come then finish. Not first 6 like this. Up to we can go up to this. First 1 then 6, 2 then 6, 3 then 6, 4 then 6, 5 then 6. Okay. And now after this our sample point will be first 1 and second also 1, not 6. 1 then 1 and then 6 and 1 then 2 then 6 and so on up to what? 1 then 5 6 and then again 2 then 1 6 2 then 1 2 then 2 2 then 2 6 and so on up to what? 2 5 6 up to 2 5 6 2 5 6 finish and then 3 1 6. Okay, just like and so on. You can write from here. We can write 5 then what? 1 6 and 5 2 6. The infinite possibilities are there. And first attempt 6 finish. First attempt 1, second 6 finish. First attempt 2, second 6 finish. First attempt 3, second 6 finish up to 5 comma 6. Now first 1 and then second not come 6. Second may come what? 1 2 3 4 5. So first 1, first 2, first 3 and the third 6. First 1 1 6, 1 2 6 and so on 1 5 6 and start from 2. First 2 then 1 2 3 4 5. So 1 1 2 1 6 2 2 6 up to 2 5 6 finish and so on. Just first 5 then 5 1 5 2 5 3 5 1 6 5 2 6 and then 5 5 6 and again not in 3 attempts 4 attempts then again write and again write and again write to the infinitive. So this is sample space for the question 16. So in this way you can write sample space for any type of events, just denoting first as a symbol and then write sample space. Okay. Try to solve some questions also from reference book. Okay, and do all examples also completed and send me 2 3 solutions for your attendance. Okay.